Imagine throwing a pebble into a pond. What happens? Ripples spread out, distorting the surface of the water. Now imagine, could the fabric of our universe behave in a similar way? This is where we introduce the concept of space-time, the backbone of our cosmos, according to Einstein's theory of general relativity. Space-time isn't merely a static stage on which celestial bodies play their parts, but a dynamic entity that is affected by the objects within it. Picture the universe as a stretched rubber sheet. When we place an object, like a star or a planet, onto this sheet, it creates a distortion, a dip if you will. This is the essence of space-time, a four-dimensional fabric that bends and warps in the presence of mass. And it's not just about the warping. The movement of objects like stars and planets are guided by this curvature, so space-time isn't just empty space, it's a dynamic entity that bends and warps around massive objects. Scene script. Ever wonder why an apple falls from a tree, or why we stay grounded instead of floating away into space? The answer lies in the fabric of space-time. Picture a trampoline, stretched taut and flat. Now place a bowling ball in the center. The weight of the ball creates a dip, a curvature in the trampoline surface. This, in essence, is how Albert Einstein's theory of general relativity describes gravity. It's not a force in the traditional sense, but a curvature in the fabric of space-time, caused by mass and energy. Take our planet, Earth. Its mass is like that bowling ball on the trampoline, causing a warp in the space-time around it. And we, like smaller balls rolling on the trampoline's surface, are drawn towards the Earth by this warping. But it's not just planets. Everything with mass or energy, from the tiniest particle to the most massive star, contributes its own dent to the universal trampoline that is space-time. The more massive or energetic, the greater the warping. This is why, despite being millions of miles away, the sun's massive warp in space-time keeps our planet in a steady orbit. What's truly fascinating is that it's not just a spatial effect. Time itself is affected, but that's a topic for another scene. So, gravity is the warping of space-time by mass and energy, and this warping tells objects how to move. What if time could slow down, or light could take a curved path? Welcome to the peculiar world of space-time. Let's delve into the phenomenon of gravitational time dilation. This is a mind-boggling concept that springs from Einstein's theory of general relativity, where time is perceived to slow down near massive objects. Just imagine a clock near a black hole would tick slower than a clock in outer space, far from any gravitational influence. Now, this isn't a mere theoretical idea, but a proven fact. GPS satellites, for instance, have to account for this time dilation to maintain their accuracy. If they didn't, we'd be lost in no time. And it's not just time that bends to the will of gravity. Light does too. When light passes near a massive object, it doesn't follow a straight line but takes a curved path, bending with the curvature of space-time. This is known as gravitational lensing. It's like the universe wearing glasses. Gravitational lensing often allows us to observe galaxies and celestial bodies that would otherwise remain hidden behind massive objects. It's as if the universe is playing hide-and-seek with us, using light as its accomplice. In the fabric of space-time, time can slow and light can bend. The universe, it seems, has a drama all its own. So, we've journeyed through the universe, exploring the fabric that weaves it together, space-time. We've grappled with the enigma of this cosmic quilt that merges the three dimensions of space with the fourth dimension of time. It's a concept that's as fascinating as it is mind-bending. We've also delved into how gravity, that invisible puppeteer, is actually a result of the warping of space-time by massive objects. This curvature guides the motion of celestial bodies, creating the cosmic ballet we observe in the night sky. And let's not forget the intriguing phenomena of time dilation and light bending. We've explored how gravity can slow down time and bend the path of light, effects that have been confirmed by experiments and observations. The next time you look up at the night sky, remember, you're not just seeing stars, but the ripples in the cosmic pond that is space-time. Subscribe to our Universal Universe channel for daily cosmic adventures.